This is a quick demonstration video for the Nottingham Hackspace. We're going to be showing how to design a part in Fusion 360 and then test it out on the Denford CNC lathe simulator, and finally, probably the second video, we'll be actually making the part on the Denford CNC lathe. So first we run Fusion 360, which is a free download from Autodesk. First thing we have to do is save our file and create a first component. Once we've done that, we start a sketch on the ZX plane, since it's a turning part, and then we quickly sketch our part, which will be a small top. Make an outline first of the basic shape. Just going to try and get the dimensions right and the main outline of the top correct. Top's going to be made out of a 15mm bar stock. So that's our basic shape done. Now we'll just add some decoration really to make it look a little bit nicer and give the lathe a little bit more to do. An arc on the end. Smooth out a couple of the other pieces. Just dimension it to show that it's going to be 15mm bar, so we want to be 7.5mm diameter, 7.5mm radius. Add some curves. Just to make the top look a bit nicer really, add a bit of bulk to it so it spins nicely. Notice that we're designing half the top here. We're going to spin it around the centre line to give a solid. Because we're going to spin it around the centre line, we don't want any internal details which would mess up our revolution solid. Put in a couple of dimensions. Shaft's going to be 2mm, so half of it's 1mm, and the top's going to be about 50mm long. We don't want a very sharp point on the end of the top. A curved end works better than a pointy end for most tops, and it stops you scratching whatever you're spinning on it. So we'll just put a radius at the point. And again trim the extra. So more or less complete. We'll just make the handle a little bit nicer. Curve at the end of the handle and tidy up some of the radiuses. Chamfer the corners. And curve the top part of the handle. And that looks pretty good. So we end the sketch. Now we've got to create a solid from our sketch. Remove solid, select the solid, select the axis, 360-degree rotation that gives us a solid. And there's our top. So we just zoom around a little bit to have a look at it, make sure the lower looks nice. Points nicely rounded, and the top looks pretty good. So that's what we'll be making. The next stage is to create the cam functions which are going to actually machine the top. So we go into the cam section. We've got to set it up first, so we set up for lathe turning, and now we've got to define our stock. So the stock will be 15mm bar. And we'll make it a little bit longer than this so we've got something to hold the end 40mm is plenty. The thing we've got to do is position our top in the stock. We want the end to be at the end of the stock, so we can hold on the back edge of the bar, of the round bar. So we'll just give ourselves 1mm or two, clean up the bar edge, and there we have it, the top hidden inside our 50mm wide bar. We'll scroll around a little bit to get it into the same aspect as we'll be seeing it on the lathe, and that's how it's going to be held in the lathe. We can see that the axis is, because of the way we drew it, the axes are already set up with the Z axis along the rotation direction. So now we set up our first tool for the facing operation. As soon as we select the tool, facing operation, 360 knows the size of the stock and the size of the object, so it automatically generates the tool path. We can now look at the tool path, just do a quick check. We can see that the blue is the cutting tool, and we can now simulate that tool path. There's our stock, hit the simulation, there's our tool come in and just cleans the end of the bar off. Right, so the next operation is a profiling operation. We can use the same tool. This will profile the front edge. We set rest machining. Just check the feed overs, reduce that a little bit from 1mm. The Denford lathe doesn't like taking large cuts, it's quite a small machine really, so 0.5mm per cut would be fine. 0.5mm step over. Say OK, and it'll generate a tool path. So there's our tool path, and it looks pretty good. Well, again, we can simulate the tool path just to see how it's going to cut. Show from the side and run the simulation. So this is the profiling operation to do the front half of the top. And that looks pretty good. So now the next step is to do a plunge operation to do the back half of the top. For that we're going to need a different tool though. So we set plunge or groove support, select a plunging stroke cut off tool. Again, check the feeds and step over. So we want a finishing pass, and there's our tool path. So that looks like a reasonable tool path. Again, we can simulate the whole thing so far. So there's the facing operation. Next we'll have the front end profiling. I'll switch to the grooving tool and groove out the back end of the top. Notice the pecking as specified in the toolpath generation. As we finish up, the piece holding it's getting a little bit thin, so we want to take quite small cuts to not snap it off. It's just cleaning up a little bit of leftover material from the first operation. You can see the shape of our top coming out. Right, the final operation is the cut off. So we now need to cut it off to get our top. New operation, cut off. Here we've got very little to do. The machine basically knows about the thing. It knows the end of the thing, it knows how to cut off, so we just set to say we want to go 3mm back, and now we can simulate the entire toolpath. Seen most of this before. The only new bit will be the cut off. So that's the profiling for the front end, grooving for the back side. Notice the grooving now goes a little bit further back because we're 3mm extra we specified, so our cut off is going to be a little bit easier. The top shape, and finally finish at the front edge, and now cut off. And there's our top. So that's the top machining completed. What we've got to do now is generate a toolpath that we can use on a Denford. So there we go to post-process, select the Denford Novaturn lathe as the output. Maximum RPM for Denford is about 3,500, 3,000 is well within its range, so we can set that up. Everything else is good, and we can say post-process. Ask for an output file, give it a name we'll remember. Save, and it generates the G-code to produce the top. Shows the G-code in the editor, and that's our G-code produced. So now we're finished with Fusion 360. Save our top so far. We now move on to the Denford Mill Simulator. The Denford Mill Simulator will only run in XP, so we're using VMware Workstation in order to be able to run it on this machine, which is running Windows 10. That's our XP machine with the Denford lathe turning software installed. Run the lathe turning software. Okay, select the virtual machine. Brings up a nice virtual lathe. We now load our toolpath, which Fusion 360 generated for us. There's the toolpath. We'll open up the... one thing we need to do is just define our stock so that the simulation works correctly. That's done with a billet command. 15mm diameter by 50mm long, and save the file. Open up a virtual thing and run the code, and there it is, running the virtual simulation. We'll expand the simulator window a little bit so we can see that in a little bit more detail, what it produced. Just zoom in a little bit. So there's our top, and now that we can see what we're actually getting, we can have it run the toolpath again. Second tool, grooving, and then cleaning up the front edge and parting off. So we should have a top. The next video will show the toolpath being running on the actual lathe to produce a nice shiny top. Thanks for watching.